Welcome to the Cimatron Wednesday webinar. My name is Andy. I work at technical support here, and I'll be walking you through this. Today we'll be covering the different cutter shapes and how to set them up, defining and setting up thread milling procedures and sequence, common problems that folks run into when setting up these procedures, how to check the posted code and make sure that your post is correctly set up for this type of procedure, and using the output window to diagnose troubles if you're having trouble with your procedure. One thing we'll want to keep in mind as we walk through today, the tool shape is not the main factor defining your thread milling motions. It will actually be in the sequence setup and what you tell it the threads per step type is. So we'll go over this again later, but just kind of keep this in the back of your mind as we walk through. The main cutter shapes you have here are the flat end mill, and then two types under the special thread mill option, which is a single tooth and a multi-tooth cutter. So these are the three shapes that you'll see and the ways that they'll view when you're looking at them. Now, when you're defining an NPT or tapered cutter, one thing to keep in mind is that we define our tooling by the tip diameter. Some cutter manufacturers do not, so just make sure that you're measuring and checking those tool tips before you set those up and use them. So let's kick over here and take a look at setting up a tool. If we go to the library here, we have some cutters set up in advance. And let's look at the quarter 20. That's a pretty common one. So you can see that the cutter technology is set to special, and the type is set to thread mill. When we do that, the first thing we'll want to look at in the catalog is the cutter diameter. In this case, it's 179. We're going to go ahead and enter the pitch. And this is the part that I think is easier if you just skip. A lot of manufacturers aren't going to define the number of threads. What they're going to tell you is the length of cut. Now, the cut length and the number of threads and the pitch are all tied together. So if I enter 0.7 in the cut length, it updates my number of threads. So don't worry about this value too much. Focus on the cut length that they give you. This is going to be an easier way to set up the tool and get what you want. From there, it's pretty standard on the setup for the shank and getting those values. The other thing that we'll want to look at is the NPT tooling. So in these, it's a little unique because we have a taper. Now this taper is going to be the same for all NPT threads. So enter your taper value, but remember this diameter here needs to be the tip of the tool. Don't forget we can do a quick investigate to view this stuff and make sure we're setting it up all correctly. So special, thread mill, enter the values, and just remember the number of threads is not the main ingredient here, but the cut length is. So when you're defining those, make sure to set that up accordingly and it'll speed things up for you. All right, so let's start setting up a procedure and sequence here. So we start with the procedure. We go to drill. We go to automated drill 3x. Now, if we were drilling water lines and everything else all around this part, we'd use 5x. In this case, we're not. So we have our auto drill. I'm going to set my stock to advanced, And in this case, I only wanted to update to show you guys what that remaining stock looks like. Part surfaces, I like to pick everything, select all, middle mouse. Group manager, again, what it's going to do is look at these holes, analyze the geometry, and it's going to group the things that are the same. In this case, all these holes are different, every one of them. So when I green check over in my automated drill tree, I will have a list of unassigned groups based on their attributes and shape. So now over here, I can right click, I can say define, and we can start setting this up. So right now we are defining a sequence to be able to program this. So from a viewing standpoint, your settings may vary. You can have this on different options like show all. I like to have this set to show active group and the rest in wireframe. I just find this easier to view. Personal preference. The next thing you'll notice is anchor points. These guys are how we tell it to machine this hole. So when we attach to these, this is how we tell it. We're going to skip this geometrical data up here for now. We're going to circle back to this. So to start, we're just going to show you guys how to get a path on this. So first thing we do is new cutter. And in this case, we need a center drill. So we're going to go ahead, put a center drill on here. We've selected it. This is a quick preview over in here. It shows you the very top and the very bottom of whatever you've defined for that particular tool. So I can see in this case right now, it's attached right to the top. I come down here and my drill type is going to be spot drill. My top reference, you can anchor to the stock. I'm going to anchor to the drill point, DP. Top delta, this is the distance in reference to my anchor point of the top. So this is the distance from the drill point up that I want it to start. I can enter a higher value, but it also works in conjunction with the delta retract. So in this case, this is the distance that is default, and it's going to switch from rapid to feed at this value. So top delta is 0 for me in this case, personal preference. Delta retract, this is where it's going to switch from rapid to feed at 1 millimeter. Bottom reference, in this case, I want it to be the drill point. But the bottom delta, I'm going to say from the drill point, go another 40 thousandths. So when we look, you can see we're just getting that start for the drill. Now that we've done that, we're going to go to new cutter again. We're going to go to drilling. I'm going to pick a cutter, or excuse me, a drill. And we need to zoom out a little here. I will again preview the depth. This time, instead of spot drill, we want a deep hole pack. I want it to evacuate the chips with each peck cycle. I'm going to anchor to the drill point at the top, retract it 1 millimeter. Bottom reference, in this case, we're going to use BT down here. And when you look at this, we can see there's a few options. I can go full diameter for the engagement. In this case, I just want the cutter tip, and you can see it carried over my values from before. I'm just going to drill that depth, and we're going to call it good. Peck is on by default because I picked the deep hole peck cycle. My step is going to be my peck increment. So I will say 50 thousandths. Decrease. Most posts and most machine controllers are not set up for this. So if you don't have this set up with us in advance, this will do nothing at your machine. I prefer to leave it at 0. Keeps it simpler. So down here, you would set your speeds, feeds, all that coolant, however you'd like. I'm not too worried about that here. So we go ahead and get to the business of thread milling. Another new cutter. We're going to go to thread mill, and I will go with this one. I will preview the depth again, and we can see this carried over values. It's way too deep. I go down here, and I'm going to pick thread milling. I'm going to anchor to the top, start at 1 millimeter, but my bottom reference this time, I'm going to reference this thread diameter that I get from Cimatron Design. And you can see I'm still going to be a little too deep, right? So I can't go this full distance. Well, I can just say, hey, reference that A thread and stay up 0.1. So there's many ways to do this. In this case, I'm going to go this route. Thread location, internal. If I had to do external, this is where I'd switch it. Thread direction, almost always right hand. Nominal diameter, this is a 1/4 thread, so 0.250 is my nominal. Thread pitch, 1 divided by 20. There's my pitch. Here's the threads per step we were talking about, guys, that we're keeping in the back of our mind. One thing you'll notice, if I left click on this threads per step right here, and I hit F1, it takes me right to help, right to thread milling, which I can click on, scroll down to here, and this gives me a nice little reminder of what I need to enter. So in this case, I have a multiform cutter that is not inserted. This is the value I need to use. So in this case, it's going to equal 0 for the cutter type. So if we change this from a 1 to a 0, we will now get the correct milling motions. I'm going to go ahead and set the cut direction. We have top down, bottom up. I'm going to use bottom up. The thread start angle, this is the approach angle to the hole. If you needed to rotate it for some reason, you can. Typically, this is going to be 0. The taper angle, if we were doing a MPT thread, this is where we would enter that value. We'd put the 1.783 in. In this case, it's a straight thread. We don't have to worry about that. Now, stock width, this is going to be based on how you drill in your final. So in this case, we have a 250 hole. We have a 204 drill. So the remainder, the difference of that divided by 2, would be what we put in here if we were trying to be exact. In this case, I'm going to use 20 thou. I'm going to use a side step of 5 thousandths. And we know right away, if we look at this cutter in this hole, we have a 204 drill and we have a 179 cutter. There's no way that this 200 thousandths for the approach and retract radius are going to work. So we have to have this as a smaller value. And this is one of the more common problems we see when someone's having trouble with a procedure not giving a result. It's simply because this value is just too big. So one place to keep an eye on and look. The tolerance is next. Again, this is typically okay at this default value, nothing to change. Approach, you can have a 2D planar or a helical. I'm going to use helical in both instances. So we're all set. This is what we need. So we're going to go ahead and green check. And we are going to save and calculate. And I am going to point one more thing out. We get a pop-up here letting us know that there are groups over here, which we have not defined a sequence. This is okay. There's no error here. There's nothing wrong. It's just letting us know we didn't program all of these. So we continue. I'm going to switch to wireframe, and we can see in a quick navigator look, here's my drill, here's my thread mill. Slow this down, and it is doing it in multiple passes. And we don't need to go all the way up because the teeth are already engaging, which is why that thread mill type matters so much. So the next thing we'll look at here is sizing the diameter of the hole, in or out. So we'll edit the procedure. We'll come over to the sequence. We'll modify it. And again, whatever's highlighted is what you're working on in here. So make sure we're on the tool we need. If the hole was too tight, here's where we would adjust this. We would bring that bigger if we need it looser, make it smaller if we need it tighter. So that's why it's good to figure out exactly where this tool likes to sit that you've ordered with the material you're working in. And once you have a good fit, this is where we want to take the next step. And you can save this and automate it for future use. That's where this geometrical data comes in up here. So you expand it. And this, I'm going to develop some ranges and restrictions for this to fit on future holes that are similar, the same geometry. So we'll start up here with the stock. I'm going to set this to NA, not applicable. For the A top diameter, I do not want this to work unless it's a 204 hole and fixed. The A thread, 1/4-20, I want that fixed. The attribute height, set to 0.5, fixed. This is a little too constricting. In this case, there may be times I have a little range on the height of that thread, and I want it to work and program the same on a few different ranges. So I'm going to put as small as 350 and as tall as 750. Now, the A height, if we look, A is down here and it runs the full height. I have this set to range, but the range is the same values. This isn't going to fit on anything in the future. So I need to make this have a little variation. So I'll go smaller for the minimum, bigger for the maximum. And then the rest of this stuff here, I'm going to ignore. So based on this information here, I'm going to give this sequence a name. So this is what I want this to be called. And I can come down here to save sequence right here. I'm allowed to adjust this preview, so this picture will save with the sequence. Apply it, and then stuff it in the folder where I keep sequences. Now when I do that, technically I haven't changed anything. The programming's still the same, but I'm going to delete this procedure, and we're going to show why we take the time to do that. This part is not required, but this is the power of AutoDrill and the speed that it can bring to your programming. So we'll make a new procedure. We'll pretend we're starting from scratch here. Let's get back to model. Part surfaces, we'll select all. Group manager, we'll select all. I will come over to the 1/4-20, right click, auto fit sequence. The only thing you have to make sure of is that it's pointing to the folder where you saved your sequence, and green check. It says for one of one groups, which I only did one group, it did find a sequence and it attached. I say okay, save and calculate. We'll switch to wireframe. And if you look, it has programmed the hole for me. So I have ranges in there, And if this hole is slightly taller or shorter, if the attribute is slightly taller or shorter, this is going to work on other parts going forward. So by taking the time to set this up now, I'm saving myself programming time later. So we can adjust, we can define the thread mill, we can adjust the diameter, we can save a sequence to auto fit this later. And then in version 16, you can take it one step further. In drill parameters, we can switch this from interactive, so the actual auto drill procedure. We can switch this to automatic. And we can point this to the folder, and we can save this as a procedure template. So in the future, again, not only can we automate the sequence, we can automate the template. So what we want to see when we program is automating as much as we can, even when we have a variety. So I would apply, I would execute, so when I'm programming, this is what it should look like. I get my target part, I get my stock. Then when I'm done, I get my procedure, I get all of my tool motions, the drilling, the milling, all of it. So without sitting here and programming every single time. And if we look, you can see the thread mill tool has updated our stock. If you'd like to see that, you can see those motions and the result in the STL there. So pretty neat, pretty fast, and a pretty powerful tool when it's set up. All right, so with posting, there's a few things that we need to be aware of. Some machines prefer to have this posted one tool at a time, or the ability to do that. That's a very easy thing to do. Highlight the procedure, come up to NC Edit, go to Other, divide procedure by cutter change. This will split everything out according to tool, so it's very easy to post individually. The next thing we need to watch for is the post set up for thread milling? When we look at the posted code, so let's go ahead and grab one of these thread mills. I am going to post this with an older post. And we'll minimize that for a second. And then I'm going to post it with a more recent post. We'll compare these two. So if we look at the difference in the code here, we have only a couple lines of code to do all of the thread milling. And if we look at the newer one, we have hundreds of lines of code. So if you don't see all this point-to-point data, your post is not set up to do thread milling. It's a very quick fix for the most part, so feel free to reach out to us at support. This is something that we can help you with. All right, move on to the next thing here. Should you need to put this back together, just delete all the splits, make your changes to the main one here, re-execute, and you're back in business. All right, the next thing we'll check out is external thread milling. So let's see this, because it is different. So when we have a post or something like this that is an external thread, this is going to look slightly different in the setup. So we still go to drill, we still go to auto drill. The big difference here is in the setup. So again, I'm going to go, just so you guys can see it, I'm going to set this to update only the remaining stock. I am going to go to surfaces and select all. I'm going to go to Group Manager, and here's where this changes. For an external thread, we're going to switch this from hole to point. We select the top of that post, green check. Now, when we anchor and group by point, it doesn't come with the same intelligence, all the anchors that we get with typical data and holes. So we have to be a little more accountable for how we set this up. So let's hit define. And you can see all of our anchors are right at the top here. We're going to select a new cutter. And this is for a 1/2-13 external thread. Again, I'll display this to make sure I'm setting this up correctly. I like to see how deep it's going to go. And we're going to go to thread mill again. The top reference, I will start at the drill point. Bottom reference, I'm actually going to use the drill point as well. And then I'm going to use a distance down from the drill point. Now, thread location, we're going to change this from internal to external. We're still right hand. Nominal diameter. This is where this is going to change as well from an internal to external. On an external thread, on an internal thread, a 1/2-13 is going to be 1/2 inch. Because we're cutting the external thread, we need to put the minor diameter in. So in this case, it is 4/67. And the pitch, again, same. And the threads per step, 0. We're going to go ahead and leave this on top down. Stock width. Side step. And the approach and retract, we have plenty of room here, so we're not too worried about that. So green check. Save and calculate. And let's go ahead and take a look at the result here. So if we display the remaining stock, we can see we did get the update. This is the correct result that we needed. So we're taking 5 passes. It's machining its way around. And we get a good result. So external thread milling, that's how you set that up. And again, guys, we'll have these files available. So should you want any of these as just a sample for setup or anything like that, they'll be available to you. All right, so the last thing we're going to go over, guys, we've covered a few things that you might run into that we see at support here. I'm going to show you guys one more thing that is super handy with any auto drill that you do. Let me throw on this real quick. And we will execute. But then we're going to edit this and purposefully break it. So down here, and this is going to be the key to this all, I have the output window. And to get that, you go to View, Pane, Output. This is a really handy tool. So I'm going to do Select All and Clear. So this window's empty. I will edit this procedure. I'm going to intentionally break this. So switch to interactive. There we go. So then the 1/4-20. I'm going to send the thread mill. We're going to shoot this down. So there's no way, right? There's a lot of drilling and milling going on here. And if I have a problem with any of it, how do we know where to start looking? So when I calculate, if I have the output window open, we can see, and I know this is going to be hard for you guys to read, but it's something that you can check when you're in here. It says the procedure was aborted to shank holder spindle gouging. So we got none of the motions, but it's all because of one thing. It actually tells me it's a part surface violation, how much, what sequence it is, what row it is in the cutter. And then it tells me, in order to prevent the gouging, it tells me what cutter to increase the length and how much to increase the length. So in this case, I go to sequence 1/4 20, I go to row 3, and this is the tool. So it actually tells me exactly where 1/4 20 goes to this cutter, and then it tells me, hey, you're too deep, the tool's not long enough. So in this case, we'll just put it back because we already knew it was fine here. But now when it goes through, we won't get this error anymore. So we'll get the motions, and we're all clear here. So this output window here, guys, super useful tool for diagnosing anything you run into, because more times than not, it's just a typo or something to that effect. And if it's a tool length issue, it'll actually point it out and tell you where it's at. I really appreciate everyone taking the time to stop in and check out this webinar today. I hope you guys can find some value in it, and these are all being posted to our new website, Cimatron.com. And for North America, if any of you guys have questions, feel free to hit us up, support-us@cimatron.com, or hit us at our main number that we've had.